week's subtitle is called Visions of the Interplanetary Probes. So these are images collected from all of the unmanned spacecraft that we've sent into our solar system, and they're very high-res, very close images of planets, moons, and other dwarf planets, comets, asteroids. So we're going to be browsing through this today. But, before we begin, I wanted to mention two things. Well, first of all, I'm pumped, and kind of overwhelming. I'm bewildered that I hit 50,000 subscribers. I honestly didn't think it would ever happen, and I just want to thank you. You all are literally the only thing that, makes that a milestone. And I just want to thank you, seriously thank you for watching, liking, and most importantly giving me feedback that you enjoy the content. So for me, this is a dream come true, that I can wake up and talk about things I'm passionate about, and you guys enjoy it, and I can help you relax and maybe sleep. So it's huge for me, and I don't intend on stopping anytime soon. So as long as you guys watch it, I'll keep making them. So I just wanted to thank you, and I try my best to interact with you guys. I literally thrive off the comments and the feedbacks, especially in the live streams. So I'll try to keep doing that. And in fact, Boast, I want to shout you out because you were speaking of interacting, it was, I didn't know if anyone would catch it, and you had the keen eye to, let's see if I still have it, to catch my little secret hidden notation in the beginning of my first Euler video. Let's see if we can find it. So yeah, just I thought that was a fun little experiment to try. I wasn't sure if anyone would catch it, but yeah, so here we go. So it starts off with hello. And they have a note. If you happen to notice this, you have a keen eye. I said in the following pages that I would shout you out, so I want to fulfill that promise. I want to follow through with that, because for me that's so huge. I can't imagine having a YouTube channel, whatever size, when I was at 500 subscribers, and now having a YouTube channel without interacting with your viewers. To me, it's cutting off any of the meaning between the videos, because I obviously enjoy talking about what I'm talking about, but it's almost doubly enjoyable to get feedback, and especially when I'm discussing things that I'm newly familiar with or not as deeply read and learned in. I love the fact that so many of you have a passion about the subjects we discuss here on the channel. So I never want to throw that to the wayside. I never want to forget you guys who have allowed this channel to achieve what it has. It's awesome. It's phenomenal. And lastly, I was approached by a few companies to do paid promotions here, and I always kind of cringed when I saw people sponsored by things that they didn't really believe in, and so I wanted to wait until there was a product, if I, could be fortunate enough to collaborate, a product that I personally would use and enjoy and believe in. And sure enough, I got approached by this awesome company that you might have watched already from my PO unboxing video. Farmer Leaf, a independent company making some awesome teas, and a plethora of them too. So I actually admittedly know very little about tea, but I know that this tastes good, and I'm already, thanks to this guy and some of my friends and family interested into tea. I grew up on coffee, but I know tea is such a unique, such a different experience. So yeah, I'm just really pumped to be able to share this with you, and this is a first for me, and it's a product that I'm really proud to be sponsored by for this video. So if you're into tea, I'm sure you guys are gonna love all their selections, and they actually have a YouTube video. I'll link to their channel. They have a slew of videos walking you through the process as they pick it right off the mountain that they're literally in. It's this village in China, and to me it's so that's the type of business I like to support, and the tea is wonderful, and I enjoy it. I've been slowly switching from coffee to tea. The code is Let's Find Out. No ASMR in there, just Let's Find Out, all one word, for a 10% discount. And I thought it would be a good idea to make this a limited offer for just 2 weeks. So let's see if you guys are interested in drinking tea, or trying something new, trying something exotic if you're not from China. 2 weeks only, and it'll be the first 50 people to enter the code to get the discount. So I hope you guys enjoy it, and yeah, I'm excited to be a part of this. So thanks, Farmer Leaf, for sponsoring the video. And I couldn't think of a better way to start this off than with a quote by the famous science fiction author Arthur C. Clarke. To put in perspective just how privileged we all are to live in this time of human history. He says, "These images are a spectacular reaffirmation that we are privileged to live in the greatest age of exploration the world has ever known." So let's go ahead and brew some tea and launch into outer space. That's so good. That's delicious. So right off the bat, we have the inner solar system, and this good diagram to show us the relative distances between the inner terrestrial planets and the outer gas giants. And then of course we have the asteroid belt right here. This looks like the sun right here. So we got an interesting table of contents right here. The Earth, Venus, Sun, Mercury, Mars, asteroids, Jupiter, Saturn, Uranus, Neptune, and then a space and time, trajectories, in and about, in and afterward. Then we have our foreword by Arthur C. Clarke. We're gonna breeze over that. That would take a whole episode just to read. So, okay, the Earth moon system right here. So, right here we have South Africa from 1999. Over here on the left, we have different satellites and spacecraft. We have Galileo, Orb View 2, TirarADeguello, and Lunar Orbiter. And down here we have the Ross Ice Shelf, snapped by Galileo in 1990. Antarctica. And it always amazes me that we can see the thin veil, the ocean of oxygen and nitrogen and other gases that we literally live in, we breathe, just like fish extract oxygen through their gills by inhaling, being immersed in water in the ocean. Every breath you take, you're inhaling the atmosphere that blankets the earth, and that is what sustains life above ground. Here is Florida upside down, going through Central America and South America. And over here we have Chile, South America. Here's an image of the Great Lakes of North America. And then these four images over here see a caption for this photograph. See if I can figure out where it is. Looks cold. And there's land. Visible land. So it's gotta be in the Arctic. If I had to guess, I would say this is the Hudson Bay. It looks like Canada and maybe Greenland over there. Between the Davis Strait between Greenland and Baffin Island, Canada. Canada 2002. Oh, it's right here. Summer in Greenland. That's funny. Now, what are these streams? See them all over. It says, this is the Pacific Ocean. And there are ship tracks, clouds from the sulfate aerosols left by large ships. It's kind of scary. A little bit disconcerting there. And we all know what this famous geographical shape is. It's so cool looking at these images that we stereotypically always look at from a specific orientation. I like how it's three-dimensional and it's on its side. Normally it's like this, but here we have Africa to the left and Europe to the right. Lush and green. Not quite as green as a rainforest. It's got some tones of brown in there, but certainly much more alive looking than the Sahara in Africa. Then we have a close-up of Sicily's Mount Etna erupting from 2002. Wow, look at that. That's amazing. It goes all the way into North Africa. And here we have Greece, Albania, Macedonia, and Turkey right there. In the whole, I guess, Middle East corridor of the Earth. And it says that this is a multi-frame mosaic. And here from 1992, we have multiple images of the Earth and the Moon. Lunar far side with the Earth beyond. From the lunar orbiter all the way back in 1962. 67, sorry. Wow. Look at that. Okay. Now here we have Copernicus, a 58-mile wide crater located within the Mare Imbrium Basin. In the foreground is the keyhole. crater Faith, 13 miles across and 4,500 feet deep. 4,500 feet deep. Wow. And you know what's awesome about these high-res close-up images of the moon? Is that if you get a decently sized backyard telescope, this is the level of detail you can see. One of my favorite things to do is look up and remember just how large the moon really is. And really, the more you think about the large celestial objects, especially like the moon, and the moon isn't even relatively that large, but it really is when you think about it. Because these craters are thousands of miles wide. If you just think about that, the United States might fit right over this. Just imagine the sheer enormity of energy being released with these impacts. And we know these craters aren't new either, so when you look at it, it's not just looking at it in the matter and the light in the moment. What you're seeing is all the activity that led to all these scars on our moon millions and billions of years ago. This image was from 1967, as was this one. When we got a fold out here. Oh my god. Wow. Try to tilt the lens a little bit there. And then back the other way. That's awesome. I'd like to get that as like wallpaper in my room here. And then wow, look at this. I've never seen a picture of the moon quite like this. It's a 200-mile wide impact crater, sometimes discernible from the Earth as the moon's southwestern horizon. And we can see the unique characteristic craters here and here. That looks like it must have nearly ripped the moon apart. And this right here these are mountains rimming the Sea of Tranquility, where humans first landed on the moon. So here is the lunar near side in the vicinity of the Campanus crater. this next one, the overleaf, is Earthrise 2 years before the astronauts saw and took the famous Earthrise that we all know. It was taken in 1965 by the Lunar Orbiter. Fantastic. That's so cool. Alright, now we're at Venus, our sister planet. The less desirable of the two sisters, no doubt. Here's Venus in an infrared image taken in 1974 by the Mariner 10 spacecraft. So what we're looking at here isn't visible light. It's the infrared light that is closely associated, correlated with heat, the thermal radiation from the planet Venus. We shouldn't read too much into the fact that Venus, the planet of love, was revealed by the Soviet and American spacecrafts in the 70s to actually be a broiling hell with 900-degree Fahrenheit temperatures on the surface. Far more interesting is the fact that the surface of this inferno, a place where rocks actually glow with heat, a place as pressurized as the bottom of the ocean, was revealed to be so incomparably beautiful by the unwinking radar eye of the early 1990s, the Magellan probe. Disturbingly beautiful, yes, even frighteningly beautiful, but beautiful nonetheless. So here, the Magellan and the Mariner 10 spacecrafts are the photographers for Venus here in this section. So the Magellan spacecraft is responsible for this image right here. And a little anecdote was that even though the Magellan spacecraft is named after a man, for the planet Venus, scientists wanted to name the geographical features after famous women, real or mythical, as the Artemis Corona and the Diana Chasm display. But they said that in order to, of course, be able to intelligibly talk about the features that were being discovered and photographed, they had to name them, as soon as possible. But it says here, a guy researching the process of this naming said, I learned later that among the 9 members of the committee selecting names for the woman's planet, there was not a single woman. The committee, in fact, was known as the 9 Wise Men. And of course, Venus is very harsh to try to probe with fragile instruments. And so it says, but although it reluctantly gave up many of its secrets to a spacecraft named after a man. The planet of love had a way of winning in the end. Stephen Saunders, a planetary geologist who had studied Venus for most of his adult life, upon learning that the Magellan spacecraft had been lost temporarily, it turns out, at the start of the first day of mapping, he famously quoted, "I felt exactly like the English astronomer in 1761 and traveled out all the way to India to see the transit of Venus across the sun, but India turned out to be cloudy, so he missed the transit, and on his way back he was shipwrecked. And when he came home, he found that his wife had married someone else and sold all his possessions. Venus really is a harsh mistress." Here we have from Magellan from 1990 to 1992. Lava flows in ridges in the Lada region. Here are the Wharton crater and the Fedorans crater. Here we have the Eretsete Mons and Spendarment Mons mountains. Some more mountains here. And it doesn't say what these lines, these kind of cross-hatched lines really are. Let's find out if it does. The Adaver crater north of the western Aphrodite highland. It says volcanic features and surface fractures in the Adla region. And then we have a series of page spreads coming up. So we're going to see a couple riffs, big riffs. Certainly not ephemeral. These have been here for a while. But it really is hard to make out the elevation because these images are from directly overhead. You can see this all here. And here is a deeper image, really showing the huge gap just dug out from the surface of the planet. Some mountains right there. And with many of these, I can't really tell if they're mountains or if they're craters. But I know there's a lot of volcanic activity on the planet Venus. And now we find ourselves back at the giver of life, the wellspring of our solar system. The light, the energy, the gravitational orchestrator, the sun. The sun, the sun. This picture is the corona of the quiet sun from 1998 from the Trace spacecraft. We have the Yoko, the Soho, and the Trace spacecrafts. Here from 2001, we have an erupting prominence. Here we have a full view of the entire disk, the entire solar disk. Let's see, the solar prominence in extreme ultraviolet light, right here. The evolution of this solar prominence. We see it start here, and then it grows, and then it reaches its perigee. Or I hope it's not apogee. Here we have the ultraviolet image. Ultraviolet image of solar magnetic plage, I guess. I don't know what the hell that means. At the base of coronal loops. Plage. And then here we have an X-ray flare, which is so cool that the scientists are able to observe the sun along so many dimensions of the electromagnetic spectrum. It's beautiful. It's an image of just the X-ray spectrum range of the electromagnetic spectrum. It really is hard to remember sometimes that the sun is literally millions and millions of nuclear bombs fusing together and exploding with energy. And the only thing really containing it is the gravitational force of the sheer amount of matter that is concentrated, and that defines what the sun really is. Okay, so here we go. This image is a solar corona we see here, which somehow is hotter than the solar, what is it? The photosphere, I think. And then over here is the rapidly cooling arcade of loops, taken in 2000 by the Trace spacecraft. Here is probably my favorite. It's just a huge eruption bursting through the sun's outer surface. And I really, really love this picture. It really captures the energy coming out. But it doesn't show the enormity, the enormous gravitational force drawing this back in after it erupts and bursts as a solar prominence, an extreme ultraviolet light. And you can see here a little loop that's on its way back in towards the sun. So this thing is a huge, it's a point at which the magnetic field, the lines of which are always reaching far outside the visible layers of the sun. It's a point at which the churning molten hyper hot atoms, they cause the magnetic field to warp so much that it twists and snaps in certain places like a rubber band. And that's sort of the weakest link in the chain through which these solar prominences burst. And of course, some do escape and become coronal mass ejections that pervade the solar system, that shoot out and project outwards. But most of the material gets drawn back in by the sun's huge gravitational field. Wow. Oh man, these are so beautiful. So here is post-flare cooling loops. Wow, look at that. Taking my trace in 2001. And then these two appear. Here's just more cooling loops, I guess. Very beautiful. I really like the way these look. They look like hot, glowing bodies of coiled wires or something, but what's really awesome is that they're the size of our frickin' planet. They're literally the size of Earth. Just imagine the awe you would be filled with if you were next to that. And we kind of are. And then our second to last page here is some more post-flare loop systems, which I suppose that means that after a burst of solar flare, a big loop goes through its process of bursting through, looping from sunspot to sunspot. It dies down and is drawn back into the sun yet again. But you have remnants of it where the sunspots still exist. And bottom here, material raining out of post-flare loops. So cool, so cool. And you gotta imagine this. They almost look like fake, but these are real images. These are real data points collected from our star, the sun. And it's so beautiful. It's so awesome to think gives us life. And it's cool to think that the sun isn't this smooth ball, but it's actually this very dynamic, volatile ball of bursting nuclear energy. This tame, relatively tame ball of nuclear energy. It's so amazing how it is overflowing with nuclear energy, pushing, bursting, constantly bursting out. Yet, that's created because the gravitational mass, the mass that creates the gravitational field, is so enormous, it won't let these solar, stellar levels of energy free. It contains it. It's so beautiful. And then our last picture here is the sun in the X-ray spectrum, exclusively in the X-ray spectrum. And this is what our sun looks like. And of course, X-rays can be damaging, but the beauty of our existence is that we're protected by Mother Earth, by our own magnetic field that deflects most of these harmful projections. So the thing that gives us life is also something that could cause death, and it's somehow we're sheathed from its violent outbursts. It's no wonder our ancestors feared and respected and worshipped the sun. And this picture was taken by Chycho, the Chycho spacecraft, in 1992. And that's it for this episode. Thanks for watching. Next time we'll pick up with Mercury and the rest of the solar system.